Study Session 3. Basic Valid Arguments Forms. Introduction. In our last study session, we examined types of arguments which include logic, proposition, and arguments. In this session, we shall examine an aspect of propositional logic basic valid argument forms. Specifically, this session will help you to know how to determine the validity and invalidity of an argument by looking at the form of the argument. The point here is that if an argument with a form X is valid, all other arguments having form X will also be valid. If, on the other hand, an argument with a form Y is invalid, then all other arguments having form Y will be invalid. To state this more clearly, the form of an argument determines the validity and invalidity of such an argument. Learning outcomes. When you have studied this session, you should be able to use logical connectives to combine simple statements to form compound statements. And lastly, identify the valid argument form that is represented by different arguments that are valid. Symbols for logical connectives. Basic valid argument forms deal mainly with the ways in which simple statements are combined together to form compound statements, as well as the validity and invalidity of arguments that can be constructed using such statements. Offor 2012, page 131. Before we go into the details of our study, however, it is expedient that we look first at the symbols for logical connectives. These symbols are indispensable in propositional logic because they help in connecting or to combine two or more simple statements to form compound statements. For instance, the statement "John is in Ibadan" is a simple statement because it has no other statement as part of its components. Whereas the statement "John is in Ibadan and Mary is studying law" is a compound statement because it combines two simple statements. Therefore, a compound statement is a statement that contains another statement as a component. Note that the connective in the compound statement cited above is the word "and", the symbol of which we shall see shortly. We must add that the components of a compound statement may themselves be compound. We have shown that compound statements or propositions are formed by using logical connectives to connect or combine two or more simple statements. Let's now look at the symbols for logical connectives by examining propositions under the following. 1. Conjunction. 2. Disjunction. 3. Conditional. 4. Biconditional. And lastly, negation. Conjunction. A conjunction is a type of compound statement which consists of two propositions joined together by words like "and", "but", "though", and their equivalents. The two statements combined to form a conjunction are called conjuncts, and or its equivalent that is placed between the two statements is symbolized by the dot sign. Thus, the statement "John is in Ibadan and John is studying law" is a conjunction whose first conjunct is "John is in Ibadan" and whose second conjunct is "John is studying law", where each of the conjuncts is represented by P and Q respectively. The above conjunction will be symbolized as P.Q. Given any two statements, say P and Q, there are four possible conditions under which the statement can be true or false. Therefore, the four possible conditions under which statements involving a conjunction can be true or false can be expressed using the following table. P.Q, TTT, TFF, FFT, FFF. The above table shows that a conjunction is true only when both conjuncts are true and false, when at least one of the conjuncts is false. Disjunction. A disjunction is a compound proposition in which two statements are joined together by inserting the logical connective, or its equivalent, between them. The two component statements of a disjunction are called disjuncts, or alternatives, and the logical symbol that represents the disjunction is the wedge, that is V. The expression John is in Ibadan or Mary is studying law is a disjunction whose first disjunct is John is in Ibadan and whose second disjunct is Mary is studying law. Where each of these disjuncts is represented by P and Q respectively, the above disjunction will be symbolized as PVQ. Given any two statements, say P and Q, the truth conditions for a disjunction can be expressed as follows: PVQ, TTT, TTF, FTT, FFF, where T stands for truth and F stands for false. The above table shows that a disjunction is true when at least one of the disjuncts is true. A disjunction is false only in case both of its disjuncts are false. Conditional. Referred to variously as hypothetical or implicative statements. A conditional is formed when two statements or propositions are joined together by placing the word if before the first and inserting the word then before them. To put this simply, a conditional statement is a compound statement of the form if P, then Q. In a conditional, the statement between the if and the then is called the antecedent, while the statement following the then is called the consequent. The logical symbol that represents the conditional is the horseshoe sign. The expression if John is in Ibadan, then Mary is studying law is a conditional whose antecedent is John is in Ibadan and whose consequent is Mary is studying law. Where the antecedent and consequent are represented by P and Q respectively, the above conditional will be symbolized as P horseshoe Q. Given any two statements, say P and Q, the truth conditions for a conditional can be expressed as follows: P horseshoe Q, TTT, TFF, FTT, and FTF, where T stands for truth and F for false. The above table shows that a conditional statement is only false when the antecedent is true and the consequence is false. Biconditional. A biconditional is a compound statement or proposition that asserts that its two component statements have the same truth value and therefore are equivalent. In other words, the two component statements in a conditional are either both true or both false, thereby implying one another. In a biconditional, two statements or propositions are joined together by the connective if and only if, where each of the two statements that form a biconditional is called a component. The logical sign that represents the biconditional is the triple bar. John is in Ibadan if and only if Mary is studying law is a biconditional. The first component in the biconditional is John is in Ibadan. The second is Mary is studying law. Where the first and the second components of a biconditional are represented by P and Q respectively, the above biconditional will be symbolized as PQ. Given any two statements, say P and Q, the truth conditions for a biconditional can be expressed as follows: PQ, TTT, TFF, FFT, FTF, where T stands for truth and F for false. The above table shows that a biconditional statement is true when either both components are true or both components are false. It is false if both components have different truth values. Negation. The statement, Mary is studying law, is negated when it is expressed as Mary is not studying law. Therefore, the negation of a statement is also referred to as the denial of that statement. A negation is a sentence which contains the word not or is equivalent, like, it is false that, it is not the case that. The logical sign that represents the negation is the tilde or coil sign. Thus, the statement, Mary is studying law, is negated when it is expressed as it is false that Mary is studying law, or it is not the case that Mary is studying law. In other words, where the statement, Mary is studying law, is symbolized as P, its negation, Mary is studying law, or is false that Mary is studying law, or it is not the case that Mary is studying law, will be symbolized as P, quote and unquote. In summary, the negation of a true statement will be false, and the negation of any false statement will be true. This is presented in the table below. PP, TF, FT, where T stands for true and F for false. Valid argument forms. Now that we are familiar with the various symbols called logical connectives, which will unavoidably come into play in our discussion of argument forms, let's now examine 9 argument forms that are valid. Remember that we have pointed out that if an argument having a form X is valid, all other arguments having form X will also be valid. If, on the other hand, an argument having a form Y is invalid, then all other arguments having form Y will be invalid. Mudde's ponens. Form P horseshoe Q. The above form can be represented by the following arguments. Premise 1. If the sun rises, then the weather is hot. Premise 2. The sun rises. Conclusion. Therefore, the weather is hot. What Mudde's ponens as a valued argument form is saying is that given a conditional statement as a first premise and the antecedent of the first premise as the second premise, then we can infer the consequence of the first premise as the conclusion of an argument. Mudde's tollens. Form P horseshoe Q. The above form can be represented by the following arguments. Premise 1. If the sun rises, then the weather is hot. Premise 2. The weather is not hot. Conclusion. Therefore, the sun does not rise. What is implied by the above is that given a conditional statement as the first premise and the denial of the consequence of the first premise as the second premise, we can arrive at the conclusion of an argument by negating the antecedent of the first premise. Hypothetical syllogism. Form P horseshoe Q, Q horseshoe R, and P horseshoe R. The above form can be represented by the following arguments. Premise 1. If the sun rises, then the weather is hot. Premise 2. If the weather is hot, then there will be drought. Conclusion. Therefore, if the sun rises, then there will be drought. Thus, hypothetical syllogism is saying that given two conditional statements as the first and second premise of an argument, and the consequence of the first premise is the same as the antecedent of the second premise, then we can arrive at the conclusion by stating that the antecedent of the first premise implies the consequence of the second premise. Disjunctive syllogism. Form PVQ, QP, or PVQ, PQ. The above form can be represented by the following arguments. Premise 1. Either the sun rises or the weather is hot. Premise 2. The weather is not hot. Conclusion. Therefore, the sun rises. Or Premise 1. Either the sun rises or the weather is hot. Premise 2. The sun does not rise. Conclusion. Therefore, the weather is hot. The above argument form is saying that giving a disjunction as the first premise in an argument and a negation of any of the disjuncts of the first premise as the second premise, then we can arrive at the conclusion by affirming the other disjunct which does not appear in the second premise. Simplification. Form P.Q or P.Q. The above form can be represented by the following arguments. Premise: the sun rises and the weather is hot. Conclusion: therefore, the sun rises. Or premise: the sun rises and the weather is hot. Conclusion: therefore, the weather is hot. The above is saying that giving a conjunction of two statements as the only premise in an argument, you can conclude by affirming any of the conjuncts. Addition. Form PVQ or PVQ. The above form can be represented by the following arguments. Premise: the sun rises. Conclusion: therefore, the sun rises or the weather is hot. Or Premise 1. The sun rises. Premise 2. The weather is hot. Conclusion: therefore, the sun rises or the weather is hot. The above implies that given a statement, you can form a disjunction of which that statement is a part, or you can form a disjunction of two existing statements. Simply put, given any proposition P, addition permits the inference that P or Q. Conjunction. Form P.Q. The above form can be represented by the following arguments. Premise 1. The sun rises. Premise 2. The weather is hot. Conclusion: the sun rises and the weather is hot. The above shows that conjunction permits statements assumed to be true to be combined in one compound statement. In other words, given two separate statements, that is premises, your conclusion simply is the conjunction of two statements. Constructive dilemma. Form in brackets P horseshoe Q dots in brackets arrow horseshoe S PVR QVS. The above form can be represented by the following arguments. Premise 1. If the sun rises, then the weather is hot, and if there is earthquake, then there will be flood. Premise 2. Either the sun rises or there is earthquake. Conclusion: therefore, either the weather is hot or there will be flood. The above argument form states that given a conjunction of two conditional statements as the first premise in an argument and a disjunction of their respective antecedents as the second premise, our conclusion will be disjunction of their consequence. Destructive dilemma. Form in brackets P horseshoe Q dots R horseshoe Q QVS PVR. The above form can be represented by the following arguments. Premise 1. If the sun rises, then the weather is hot, and if there is an earthquake, then there will be flood. Premise 2. Either the weather is not hot or there will be no flood. Conclusion: therefore, either the sun does not rise or there is no earthquake. The above argument form states that given a conjunction of two conditional statements as the first premise in an argument and a disjunction of their negated consequence as the second premise, our conclusion will be the disjunction of their negated antecedents. Study session summary. In this study session, We have explored the symbols for logical connectives because these symbols are indispensable in propositional logic. You consequently learned how to determine the validity and invalidity of an argument by looking at the form of the argument. End of study session 3. Thank you for listening.